Hello students, how are you? Okay, let's start the chapter Mechanical Properties of Fluids. What is fluid? A fluid is a substance that can flow. The term fluid refers to both liquids and gases. Now, fluid statics. The branch of physics that deals with the study of fluids at rest is called the fluid statics or hydrostatics. Now, the fluid dynamics. The branch of physics that deals with the study of fluids in motion is called the fluid dynamics or hydrodynamics. Thrust. What is thrust? The total force exerted by a liquid on any surface in contact with it is called the thrust. A liquid always exerts force perpendicular to the surface of the container at every point. Now the pressure. What is pressure? The thrust exerted by a liquid per unit area of the surface in contact with it is known as the pressure. Pressure equal to thrust upon area or P equal to F upon E. Density. What is density? The density of any material is defined as its mass per unit volume. Density equal to mass upon volume. Rho equal to M upon V. Unit and dimension of the density. The SI unit of density is kilogram per meter cubic and dimensional formula of density is ml to power minus 3. Specific gravity. What is specific gravity? The relative gravity or specific gravity of a substance is defined as the ratio of the density of the substance to the density of the water at 0 degree at 4 degrees centigrade. Specific gravity equal to density of the substance upon density of the water at 4 degrees centigrade. Now the Pascal's law. What is Pascal's law? It states that a change in pressure applied to an enclosed incompressible fluid. It states that a change in pressure applied to an enclosed incompressible fluid is transmitted undiminished to every point of the fluid and the walls of the containing vessel, or the pressure exerted at any point on an enclosed liquid is transmitted equally in all directions. Hydraulic lift. What is hydraulic lift? It is an application of Pascal's law. It is used to lift heavy objects. According to Pascal's law, pressure applied on a smaller piston equal to pressure transmitted to larger piston. P equal to F1 upon A1 equal to F2 upon A2. Here A2 is greater than A1, so F2 is greater than F1. Thus, hydraulic lift acts as a force multiplier. Pressure exerted by a liquid. A liquid column of height h and density rho exerts a pressure given by P equal to rho g h. Effect of gravity on fluid pressure. Effect of gravity on fluid pressure. The pressure in a fluid varies with depth h according to the expression P equal to Pa plus h rho g, where rho is the density of fluid and Pa is the atmospheric pressure. Hydrostatic paradox. Hydrostatic paradox. What is hydrostatic paradox? The pressure exerted by a liquid column depends only on the height of the liquid column and not on the shape of the containing vessel. Atmospheric pressure. What is atmospheric pressure? The pressure exerted by the atmosphere is called the atmospheric pressure. At sea level, we have atmospheric pressure equal to 1.013 into 10 to power 5 Newton per meter square. Absolute pressure and gauge pressure. Absolute pressure and gauge pressure. The total or actual pressure P at a point is called the absolute pressure. Gauge pressure is the difference between the actual pressure at the point and the atmospheric pressure. Pg equal to P minus Pa. Absolute pressure equal to atmospheric pressure plus gauge pressure. Now, buoyancy and center of buoyancy. The upward force acting on a body immersed in a fluid is called the upthrust or buoyant force, and the phenomena is called the buoyancy. The force of buoyancy acts through the center of gravity of the displaced fluid, which is called the center of buoyancy. Now, Archimedes principle. What is Archimedes principle? It states that when a body is immersed partly or wholly in a fluid, it loses some weight. The loss in weight is equal to the weight of the fluid displaced. Apparent weight of a body in a fluid equal to true weight minus weight of the fluid displaced. Law of inflation. Law of flotation. What is law of flotation? A body will float in a liquid if weight of the liquid displaced by the body is at least equal to or greater than the weight of the body. When a body just floats, weight of the body equal to weight of the liquid displaced. Viscosity. What is viscosity? It is the property of a fluid due to which an opposing force comes into play whenever there is relative motion between its different layers. Viscosity is the measure of a fluid resistance of flow. It describes the internal friction of the moving fluid. A fluid with large viscosity resists motion because its molecular makeup gives it a lot of internal friction. A fluid with low viscosity flows easily because its molecular makeup results in very little friction when it is in motion. Gases also have gases have also viscosity, although it is a little harder to notice in an ordinary circumstances. Newton's formula for viscous forces. The viscous drag between two parallel layers, each of area A and having the velocity gradient dv upon dx is given by F equal to minus neta A dv upon dx, where neta is the coefficient of viscosity of the liquid. Now the coefficient of viscosity. What is called the coefficient of viscosity? It may be defined as the tangential viscous force required to maintain a unit velocity gradient between the two liquid layers, each of unit area. It may be defined as the tangential viscous force required to maintain a unit velocity gradient between the two layers, each of unit area. Now the Stokes law. What is Stokes law? It states that the backward dragging force of viscosity acting on a spherical body of radius r moving with velocity v through a liquid of viscosity neta is given by F equal to 6 pi neta rv. Now the terminal velocity. What is terminal velocity? It is the maximum constant velocity attained by a spherical body while falling through a viscous medium. The terminal velocity of a spherical body of density rho and radius r moving through a fluid of density rho dash and viscosity neta is given by V equal to 2 upon 9 r square neta rho under the bracket rho minus rho dash into G. Streamline flow and turbulent flow. What is streamline flow and turbulent flow? It is the flow of liquid in which each particle of the liquid passing through a point travels along the same path and with the same velocity as the preceding particle passing through the same point. A liquid possesses streamlined motion only when its velocity is less than the certain limiting value. Is that limiting value is called the critical velocity. When the velocity of the liquid becomes greater than the critical velocity, the particle below zigzag the particle follow zigzag path. Such a discordant or irregular motion is called the turbulent flow. Now the tube of flow. A tube of flow is a bundle of streamlines having the same velocity of the fluid over any cross section perpendicular to the direction of flow. Laminar flow. What is laminar flow? The steady flow in which the liquid moves in the form of layers is called the laminar flow. The velocity of the layers varies from maximum at axis to zero for the layer at the wall of the tube. Critical velocity. Now the critical velocity. The critical velocity of a liquid is that limiting value of its velocity of flow onto which the flow is streamlined and above which the flow becomes turbulent. It is given by Vc equal to k neta upon rho into r. Here r is the radius of the tube and rho is the density of the liquid. Reynolds formula. What is Reynolds formula? It is a dimensionless number which determines the nature of the flow of the liquid. For a liquid of viscosity neta, density rho, and flowing through a pipe of diameter d, Reynolds number is given by Re equal to rho v d upon neta. Ideal fluid. What is ideal fluid? An ideal fluid is one which is non-viscous, incompressible, and its flow is steady and irrotational. Ideal fluid is one which is non-viscous, incompressible, and its flow is steady and irrotational. Rate of flow. What is rate of flow? Rate of flow. The volume of a liquid flowing per second through a pipe of cross section A with velocity v is given by q equal to v upon t, and that will be equal to a into v. Now the equation of continuity. Equation of continuity. If there is no source or sink of the liquid along the length of the pipe, if there is no source or sink of the liquid along the length of the pipe, the mass of the equation of continuity. Now the equation of continuity. If there is no source or sink of the liquid along the length of the pipe, the mass of the fluid crossing any section of the pipe per second is always constant, and m equal to a1 v1 into rho 1 equal to a2 v2 into rho 2, and this is called the equation of continuity. For an incompressible liquid, rho 1 equal to rho 2, and that will be a1 v1 equal to a2 v2, or av equal to constant. Thus, during the streamlined flow of a non-viscous and incompressible fluid through a pipe, the product of area of cross section and the normal fluid thus during the streamlined flow of a non-viscous and incompressible fluid through a pipe of varying cross section, the product of area of cross section and the normal fluid velocity remains constant throughout the fluid flow. Now, Bernoulli's principle. What is Bernoulli's principle? It states that the sum of the pressure energy, kinetic energy, and potential energy per unit area of an incompressible non-viscous fluid in a streamlined flow, irrotational flow, remains constant along a streamline. I am repeating once again the statement. It states that the sum of the pressure energy, kinetic energy, and potential energy per unit volume of an incompressible non-viscous fluid in a streamlined Its irrotational flow remains constant along a streamline. P plus half rho v square plus rho gh equal to constant. Bernoulli's equation takes the form P plus half rho v square equal to constant, or it can be written as P1 plus half rho v1 square equal to P2 plus half rho v2 square. It indicates that the velocity increases when pressure decreases and vice versa. Torricelli's law. What is Torricelli's law? It states that the velocity of efflux, that is, the velocity of which the liquid flows out of an particle. Torricelli's law. What is Torricelli's law? It states that the velocity of efflux, that is, the velocity of which the liquid flows out of an orifice, a narrow hole, orifice means narrow hole, is equal to that which a freely falling body would acquire in falling through a vertical distance equal to the depth of the orifice below the free surface of the liquid. Hence, the velocity of efflux of a liquid through an orifice at depth h from the liquid is given by v equal to under root 2gh. Magnus effect. What is Magnus effect? The difference in the lateral pressure which causes a spinning ball to take a curved path which is convex towards the greater pressure side is called the Magnus effect. I am repeating once again. The difference in the lateral pressure which causes a spinning ball to take a curved path which is convex towards the greater pressure side is called the Magnus effect. Cohesive and adhesive forces. Cohesive and adhesive forces. The force of attraction between the molecules of the same substance is called the cohesive force, while the force of attraction between the molecules of the two different substances is called the adhesive force. Now the molecular range. What is molecular range? It is the maximum distance up to which a molecule can exert some molecular attraction on another. Molecular range. What is molecular range? It is the maximum distance up to which a molecule can exert some measurable attraction on one another molecules. The order of molecular range is 10 to power minus 9 meter in solids and liquids. Surface film. What is surface film? A thin film of liquid near its surface and having the thickness equal to the molecular range. For that liquid is called the surface film. The surface tension. Now I am going to explain you about the surface tension. It is the property of a liquid by virtue of which it behaves like an elastic stretched membrane with a tendency to contract so as to occupy a minimum surface area. It is measured as the force per unit length of an imaginary line drawn on the surface of the liquid. Surface tension equal to force upon length, or it can be written as F upon L. Excess pressure inside a drop and bubble. Excess pressure inside a drop and bubble. There is excess pressure on the concave side of a curved surface. Excess pressure inside a liquid drop 2 sigma upon rho, one free surface, and excess pressure is inside a liquid bubble 4 sigma upon r, two free surfaces. Excess pressure inside an air bubble 2 sigma